Hello, good day everyone. You are welcome back to Class Bridge. Now, today we are going to be looking at two important aspects in vector analysis. The first one is dot product, the second one is the cross product. Now, you will observe that we have been taking our time to dwell on the fundamentals of this course. The truth is that we are not stupid and we are not foolish. What we believe as a tutor is that the amount of deeper knowledge you will be able to build on this particular course later in the future is the function of the amount of the fundamentals you really understand. And that is the truth. Now, over the years, I have seen students who can actually use formula to calculate and get answer to dot product. Same thing with cross product. But many of them actually lacks the understanding and the rationale behind the dot product itself. And that is why we are here at ClassBridge, to bridge the gap between what you know and what you should understand. So let's get to class. Let's get to business. What is dot product? Now I need to tell you something. In vector, we have two types of multiplication in vector. One is the dot product. When you check some textbook, they will call it scalar multiplication. And this is the operator we use to denote it. Right? The second one is the cross product. Right? And when you take this kind of multiplication, it will give you another vector. And this is the operator we use to denote that. Very good. Now, like I've said, dot product, when you have two vectors that has both magnitude and direction, right? Vector A and vector B. And we are taking the dot product of these two vectors, they are going to give us a scalar value. When we have two vectors, say A and B, when you take the cross product of that vector, it is going to give you another vector. Very good. Now, so the question is, what is this dot product you are talking about? It is very simple. As for me, I see dot product as a measure of alignment. Please get it clear. I see dot product as what? A measure of what? Of alignment. But some textbook will say the dot product is defined as a measure of how much one vector is going in the direction of the other. So we are saying that the dot product is defined as a measure of how much one vector goes in the direction of the other. So we are saying dot product is defined as a measure of how much one vector goes in the direction of the other. You might be finding it hard to get what we are saying, but just take note of the word measure of alignment. How much one vector goes in the direction of the other. You see, when a concept looks like this, I always like to use diagram. So I've prepared some diagram. Let's see and let's analyze. Now, let's see this figure here. I know you can see the vector A, right? And you can see the vector B. And you can see X, which is their measure of alignment, right? But me, I'm seeing something different. I'm seeing a couple that has the same intention, right? Take for example, the husband, which is A, said to the wife that, oh, my darling wife, I want to go and watch football, right? And the wife said, ah, that has been on my mind. So you watch football too? Yes, I watch football. In fact, I'm a Chelsea fan. Oh, wow, you're a Chelsea fan? I'm also a Chelsea fan. Let's go there. What do you see? Their intention is what? The same, right? And at this point, what do you observe? The key things you need to note is that when two vectors has the same intention, which means when they are going in the same direction, just like A and B does here, the dot product, their dot product is very large. Dot product is very large. When what? When two vectors has same intention. But here we call it what? Direction. They are moving towards the same direction. And if you check some textbook, if your textbook is very good, they will say at 0 degree, that is when we have two vector and the angle between them is 0 degree, just like we have here. At 0 degree, the vector's alignment is maximum. Two things we note here. When two vectors move in the same direction, exactly the same direction, what happen? Their dot product is what? Very large. And also, if the angle between the two vectors is what? 0 degree, then we say it has what? Maximum alignment. So this is case one, right? Let's see another one. Yes, this is the second figure. Now, what do you see here? You will observe that we have, this is still the same thing we have, this is still the same figure we have above. But what we do is that we keep the magnitude of A, we also keep the magnitude of B, right? But what do? We tilt vector B to a certain angle. That's what we do here. And what do you observe? Obviously, what do you observe? You can now see that we call X the measure of alignment in the first case. Y is also the measure of alignment here. But the measure of alignment we are seeing here is when the vector B has been tilted to a certain angle, right? And what do you now see? You will now see that the measure of alignment for X is greater than what? Y. And here, we say X is what? Greater than Y. Very, very obvious. And here, what do you see? You should now observe something here, that the more we tilt this vector B to a certain angle, the lesser the measure of alignment becomes. Are you getting my point now? The more we tilt the vector B to a certain angle, the lesser the measure of alignment between B and vector A. It's as simple as that. Right? Very good. Now, here we can deduce that the more the angle between vector A and B, the lesser their measure of alignment. So let's see another figure. Let's see another figure. So this is the third figure. Here we can see that the angle beta is greater than 60 degree but less than 90 degree. So what do you still observe? The more we tilt, the more we increase the angle between A and B, the lesser their measure of alignment. So with this, you should get what dot product is all about, right? So we can just say that we observe that x is greater than y, but y is what? Greater than z, right? It's as simple as that. X is greater than y is greater than z. And another thing is that the more we increase the angle between A and B, just like we said the other time, the lesser their measure of alignment. It's as simple as that. Now, you now see that it will get to a point whereby their alignment will be totally different. What do I mean? Let's use a scenario whereby the husband is saying, for this Christmas, we will be going to my family house, right? And the wife is saying, no, you should go, or we should go to my own family house. So their intention is actually totally different. It means that what happens when the angle between the two vectors is equal to 90? What is going to happen? Let's see. So in this case now, we can clearly see that the angle between A and B is 90 degree, and they are looking totally in different direction, right? What is going to happen here is that you will now see that we can deduce that the measure of alignment here is 0. The measure of alignment here is 0. It's as simple as that. So here there is no measure of alignment, right? It's as simple as that, because the vector A is looking towards a direction and vector B is looking towards another direction entirely. So I will give you this assignment. What will happen? So you can drop the answer at the comment box. What will happen if the theta, if we now have theta is greater than what? 90 degree. What is going to happen if theta is greater than 90 degree? Or if I want to rewrite it again, I can just say 90 degree, which means that theta is greater than 90 degree but less than what? 180 degree. So I want this answer. So with this 4 illustration, right, I believe that we now understood what dot product is actually talking about. We understood what dot product is talking about. Now let me give you a quick summary. I have said that the dot product is what? Is the measure of alignment. the measure of how much one vector goes in the direction of the other. And I said it that if the angle between the two vector is 0 degree, then their dot product will be very large. And in fact, some textbook will say it has what maximum what alignment. So it's as simple as that. But once you begin to what increase the angle between them, something is going to happen. Their measure of alignment will decrease. So that is all. Very, very simple and straightforward. Now, let's talk more about dot product. Now, in mathematics, dot product has two major representation. We have two ways we can actually represent dot product. The first one is that we can represent dot product algebraically. So let's talk about the algebraic representation of vector. So we want to talk about the algebraic representation of dot product. Now, how do we represent dot product algebraically? We say if we have a vector A to be what? A1, B1 and C1. Also, we have vector B to be what? A2, B2 and C2. So when we take the dot product of these two, what do we have? So it implies that we'll be having dot B will be equal to, it will be equal to what? The sum of the product of each component. It's as simple as that. Let me put it down and you will see. So we take the product of these components A and A. So we'll be having A1, A2 plus B1, B2 plus C1, C2. It's as simple as that. Just take those components A, you multiply them together, plus B, you multiply them together, plus C, you multiply them together. It's as simple as that. So which means that when we take the dot product of these two, it is going to give us what? I've said it earlier. It's going to give us a scalar value. It's going to give us a scalar value. It's as simple as that. So we have scalar value. So let's take an example here. So we want to find the dot product between these two vectors. Don't forget that from the algebraic representation, we have said that the vector A dot B is equals to what? A1, A2 plus B1, B2 plus C1, C2. What does this imply? So you can now see that A1 is equals to what? 4. B1 is equals to what? 2. And C1 is equals to what? 1. You can see. Also, A2 will be what? 3. B2 will be 0. And C2 will be what? Will be minus 1. So it's as simple as that. So when we multiply them, when we take the dot product, so we have what? What is A1? That is 4. 4 times what? A2 is what? 3. 4 times 3 plus 2 times 0, abi? Plus 1 times minus 1, right? So this will give us what? 4 times 3 is 12 plus 0. 1 minus 1. 1 times minus 1. That is minus 1. Right? So what do you see? We have it to be what? 12 plus 0. 0 minus 1. That is 11. So it's as simple as that. You can say 11 units. It's as simple as that. So let's take another one. So the question can also come in this format. So what do we need to do? It is very simple. You can also change it to look like what we have initially. So which means that we can rewrite that as what? 3, 2, 4, right? And B will be what? Vector B will be what? 2, 6, 3. Just to look for their dot product now, you know what to do. You multiply them component wise and add them. So we have A, B to be equals to what? 3 times 2 plus 2 times 6 plus 4 times 3. As simple as that. Dot product, very, very simple. 3 times 2 will give us 6 plus 12 plus 12. So 6 plus 12, that is 18, right? 18 plus 12, and this will give us what? 30. As simple as that. Also, here I need you to note that I think I've said it in one of my video, but I still need you to note that in vector, when you multiply dot product, I dot I is equals to I square, right? And this will give us what? 1. J dot J is equals to J square, abi? And this will give us 1. Please note, K dot K is equals to K square, and this will give us what? 1. You will need it. But whenever you multiply them with different components, their answer will always be 0, which means that I dot J is equals to I dot K is equal to J dot K is equal to 0. So when you multiply them with another component, you get it? When you multiply them with different components, it will be 0. So it's as simple as that. But when you multiply I and I together, it is 1. When you multiply J and J together, it is 1. So it's as simple as ABC. And that is why when we are saying dot product, some of you will think we are supposed to multiply like we multiply in normal basic mathematics. This is the reason why we don't do that, because even when we do, it will amount to 0. So it's as simple as ABC. So now let's move on to the second representation of dot product, which is what? The geometrical representation. The geometrical representation. So let's talk about the geometrical representation of dot product. Let's say that given vector A and vector B, right? It has magnitude, it has direction. Their dot product A dot B is equal to the magnitude of vector A times the magnitude of vector B, right? Multiplied by the cos of the angle between them. Theta is what? The angle between A and B. Very, very simple. Now let's use this concept Let's use this concept to solve question on the image we show earlier, right? Let's try. So what do we want to do here? We want to really confirm and show that indeed dot product is the measure of alignment, and all the observations we have made earlier are genuine, right? Very good. So what we need to do now is to give vector A value and give vector B a value. Then we begin to what? Increase the angle between them to confirm and to see if truly their measure of alignment will actually shrink as we increase the angle. So let's see. Let's say A, our vector A, let's give it 20. Let's assume the magnitude is 20, right? Okay, let's assume the magnitude is 20. Let's assume vector B, the magnitude is 10. Let's just assume. And here, for this case now, theta is 0. Good. We want to look for the dot product, abi? The dot product, which imply that we have said it will be the magnitude of what? A, and it has been given, which is what? 20. And the magnitude of B is what? 10, right? Cos 0 degree, abi? Theta is 0 degree. So what do we have here? 20 times 10 is what? 200. Cos, abi? 20 times 10 will give us 200 times, what is cos 0 degree? That is 1, abi? Very good. So it implies that A dot B is equals to 200 here. You can see. Now for the second one, 2, we say A, abi, is equal to 20, B is equal to 10. Those are the magnitude, right? Why theta here, let's say, is equal to 30 degree. Let's say it's equal to 30 degree. So our dot product here will be what? Our dot product will be 20 times 10 cos 30, right? So 20 times 10, what is cos 30? Cos 30 should be root 3 over 2. Root 3 over 2, right? So what do we have? We have our dot product to be what? Our dot product to be 20 times 2 goes here. We have 5, right? 20 times 5, that is 100. So 20 times 5 root 3. 20 times 5 is 100. That is 100 root 3. It's as simple as that. So you can see 100 root 3 is definitely less than what? 200. So let's see the next one. So here we can still say that A, vector A is still what? 20. B is 10. But theta here is, let's say, 60 degree. So what do we have? A dot B is equal to, we have 20 times 10 cos 60 degree, right? So we have 20 times 10 cos 60 is what? 0.5. That's, yeah, 0.5. 0.5. 1 over 2. So it implies that we'll be having A dot B will be equals to 20 times 10 times 0.5, that is 5, right? And that should give us 100, if I'm not mistaken. 100. Okay. So the last but not the least, we are having is equal to 20. We are still keeping it. Vector B is equal to 10, but our angle here is equal to, our theta here is equals to 90 degree. So what does that implies? Our dot product will be equal to 20 times 10 cos 90 degree, which will give us what? 20 times 10 cos 90 is what? 0. What do you observe? It implies that 20 times 0, 10 times 0 is 0, 20 times 0 is 0, which means that our dot product here will be what? 0. So everything stated earlier is very, very correct. You can see as we increase the angle between them, what happen? Their measure of alignment, their dot product what? Decreases. And when the angle between them is equal to 0, we have maximum measure of what? Alignment, which is what? 200. Very, 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 very simple. So it's not just about solving. Do you really get what is going on? Do you really understand the concept? That is why we are trying to ensure that you understand the what? The fundamentals here. So it's as simple as that. So let me just give you this assignment. Try this. We still have what? The magnitude of A to be 20, B to be 10, but here the angle between them is 135 degree. So you can do that. Then we meet again where we'll be talking about the cross product.